Okay, so what I'd like to do in this video is tell you about that proton-proton chain that makes the energy in the sun. And the proton-proton chain does boil down to a hydrogen plus a hydrogen coming together to form helium plus energy. This is sort of the net sum of it for sure, but I want to show you all the details in there just to show you what indeed is going on inside the sun. So what I'll do is a bit of a nomenclature too as I get started here is, first of all, whenever I draw a dot like that, maybe I'll put a P below it. This is always going to stand for proton. And when I draw an N with a circle around it, as you might guess, that's always going to be a neutron. And whenever I draw, I guess, well, I think that'll probably do it. I was going to say whenever I draw an H like this, this will correspond to hydrogen. And we'll just leave it at that. So let's see how we go. Okay, so the proton-proton chain, here we go. You're visualizing the sun now at the sun's core, having all these protons in them zinging around. And the first thing that happens is a proton is going to come together with another proton. And what they're going to do, they're going to sort of quote unquote react with each other to form a proton and a neutron. And they're also going to let out something called a neutrino plus a positron. Okay, so a couple things. We mentioned the positron up above. Let me just scroll back up there for a minute here, because the positron is one of the particles that can possibly be positive. There it is right there. There's the positron, so that comes out. And the neutrino here is something that comes out, which is sort of an exotic subnuclear particle that I'll leave at the moment. It just sort of passes through all matter, and we'll talk about those maybe in a future lecture, but it's just something that comes out. Back to the core constituents of the reaction then. Keep in mind that this is none other than a proton, just a proton. The way I've described, I would sort of write right up there. And then what comes out is kind of interesting here too, because what this is another proton. There's the P right there, and there's a neutron there too. So what is just a proton and a neutron? Well, remember we said that the number of protons something has identifies the atom. And so when it has one proton, do you remember what atom that is? Well, yeah, it's just hydrogen. So this is a form of, this is hydrogen here, one proton. This is hydrogen here, one proton. And this also has one proton, so it's just going to be hydrogen, but we're going to put a little 2 next to it, because what the 2 means is that there's 1, 2 sort of particles in the nucleus of this one here. So it's a bit heavier than these. See, these just have a proton. This has a proton and a neutron. So we put a 2 there, and it's a bit heavier. And it also has a name. It isn't typically called just hydrogen anymore, but it's called deuterium. And the neutrino and the positron come out. So there's your first step in the core of what happens to the sun. All these protons bouncing around. 2 of them are going to come together. They're going to form heavy hydrogen, or deuterium, and a neutrino and a positron are going to come out. So I'm going to take a pause in the action here, because this seems on the one hand so easy. But remember what a proton is. A proton is a positive charge, and this other proton is a positive charge. So I thought we said way up above that when these particles come together, they want to repel, remember, because they're like charges. They want to repel each other. So the question that then, if these two want to always repel each other, how is it that they're coming together? It seems like the closer and closer they get, the more and more they want to get away from each other, and that in fact is true. So how is it that they're able to come together in the sun? Well, let me show you in this simulation over here now. So what I have here in the simulation is basically a big tank I can fill full of gas. So if I take this bike pump and sort of give it a pump here, you see all the gas starts to go in, and maybe I'll pump it a few more times. And what starts to happen when the gas gets in there and starts bouncing around, that you can see the pressure here starts to rise a little bit, because these gas molecules are hitting the side of the container. And here's what happens in the sun. So what you can do at the moment is think of all these little blue or purple balls here as the hydrogen in the core of the sun. And our question is, how is it that they're able to come together and form this deuterium and the neutrino and the positron if they have the same charge? They don't want to come together. Well, remember what happens when things get really hot. So we turn the flame up here. Watch what happens to the pressure up here. Let me keep the flame on, but watch this number right here as I go up. And maybe also watch the molecules, or the blue or purple balls in there. See, they start moving a lot faster, don't they? Faster and faster and faster. And if I sort of keep doing this, the pressure gets so high in there that I think at some point is going to go, I think I can even blow that top off there, but look at how those particles are just zinging around in there until they actually blow the lid off. And so that's just what happens when you heat up a gas. The pressure starts to rise. So if I go back to our discussion here, that's how the sun is able to cause these two protons actually to come together. So if one proton is going this way and the other is going this way, I totally agree with you that there'll be a force this way and a force this way trying to keep them apart because they're like charges, but they're going so fast this way and so fast that way, as I showed you in the simulation, that they actually will come together. So they can get really, really close together like this to the point, and this is where we say they fuse. They fuse together, and of course fuse is that first word in fusion, which is what drives energy in the sun. Okay, more on proton-proton in the next video.